Hi students, today we'll go for another important concept in atomic structure, that is nothing but Bohr's atomic model. So here, if you observe Bohr's atomic model, in this the concepts what we have to discuss in view of objective examinations. That is, as you know, according to Bohr's model, here we are having the nucleus at the center of the atom, and around that we have circular orbits like this, and in these orbits the electrons are revolving and they are designated as K, L, M, N, like that. Those are the circular orbits, that too they are stationary orbits. Means as long as electron is revolving in that particular orbit, its energy remains constant. That's why they are known as stationary orbits. Now, one of the important point here regarding that stationary orbit means there is one postulate in Bohr's model, that is nothing but the angular momentum of the electron which is revolving in that stationary orbit is an integral multiple of h by 2 pi. So now, if you observe that postulate, angular momentum mvr, that is equal to n into h by 2 pi, where n is nothing but principal quantum number, which is nothing but number of the orbit. Means if you observe K shell, its n value is 1, first orbit, and L shell 2, M shell 3, N shell 4, and so on. So that is what we call as n, which is nothing but principal quantum number. And here the value of n, it gives an idea about the main energy level of the electron, means in which orbit the electron is present. That information we are getting with the help of n value. Now, based on this, in objective pattern, see, suppose if electron is in first orbit. Now see here, in first orbit means K shell, here n equal to 1. Now, in this first orbit, angular momentum mvr equal to 1 into h by 2 pi. Similarly, in L shell, n equal to 2, where mvr, that is equal to 2 into h by 2 pi, or we can write as h by pi. Regarding that too, we will discuss later. So like that, here by substituting that n value, we are getting the angular momentum of the electron. So this is the postulate what he proposed. Now, in our objective pattern, see, since mvr equal to n into h by 2 pi, here we can mention the formula in two ways. This is one way, and another one, that is mvr equal to n by 2 into h by pi, where h by pi is constant. So thereby, here we can consider as n by 2 into k, where k is constant, which is equal to h by 2 pi. So be clear about these two types of notations. One is n into h by 2 pi, another one is n by 2 into h by pi. So by observing the question keenly, you will get in which form they expressed the angular momentum of the electron. By using that, you have to find out n value. And one more, based on this, if you observe K shell, mvr, that is equal to 1 by 2 into k, which is nothing but 0.5 k. Similarly, in L shell, mvr, that is equal to 2 by 2 into k, which is nothing but 1 k. And in M shell, means third orbit, mvr equal to 3 by 2 into k, which is nothing but 1.5 k. So like that, if the value of n is going on increasing, angular momentum of the electron is increasing by a factor of 0.5. So that point you have to remember. See, in first orbit 0.5 k, in second orbit 1 k, in third orbit 1.5 k, in view of this one. So that means here the difference in angular momentum of the electron between any two successive orbits, that will be nothing but 0.5. So as the statement you have to remember. Means, suppose if you observe the angular momentum in second orbit and angular momentum in first orbit, the difference in those angular momentums, that will be equal to 0.5. Or third and second, difference is 0.5. Fourth and third, 0.5. So like that, here along with n value, in successive way, angular momentum of the electron in those stationary orbits is increasing by a factor of 0.5. That is one important point. Or the difference in angular momentum of the electrons between any two successive orbits, that is nothing but 0.5. So you should remember this in the form of statement. That is one point. And next another one, see, suppose here there is one question. In hydrogen atom, the angular momentum of an electron means they are giving angular momentum MVR, which is equal to, for example, 1.5 into h by pi. So if the angular momentum of the electron MVR equal to 1.5 into h by pi, then what is n value? Now see that question. Already I gave two formulas. One is MVR equal to n into h by 2 pi, and another one is n by 2 into h by pi. Now it is in this form. That means MVR equal to n by 2 into h by pi. So if we compare the two expressions, here n by 2 equal to 1.5. So therefore n equal to 3. That means that electron is present in third orbit or M shell. So like that, you have to find out the value of n. After that, once if you get the value of n, here we can use that n value in different ways that we will see in next concepts. But the way how to find out the value of n. So if it is like this, here n equal to 3. Now observe the same question. Angular momentum of the electron in an orbit, that is, for example, 3 into h by 2 pi. You have to observe the difference between the previous question and this question. In previous question, 1.5 into h by pi, but here it is 3 into h by 2 pi. So now they mention in this form, that is MVR equal to n into h by 2 pi. So if you compare the two expressions, as per this, n equal to 3. So like this, be careful while observing the question, whether it is in MVR equal to n into h by 2 pi or MVR equal to n by 2 into h by pi. So this is one important part as far as angular momentum concerned. And one more, suppose if they are giving angular momentum of the electron in that orbit, what about its kinetic energy? That is another relation. That means relation between kinetic energy and angular momentum. So relation between kinetic energy of the electron and its angular momentum. So now here, think as far as the Neet pattern concerned, we are not going to expect any calculation, but we should know the relation between those two as the general expression. In mains pattern, we can expect the question. So now, how to derive the relation between kinetic energy and angular momentum of the electron? Now see this. Suppose if angular momentum of an electron, let it be x, then what is its kinetic energy? So that is the question. Now see, they mention angular momentum as x. So if you observe the solution, since x equal to mvr, therefore x square equal to what? M square v square into r square. Now I can write this relation in this way, that is mv square into m into r square. So x square equal to mv square into mr square. I think now you will get an idea how to get kinetic energy. Now if you consider x square by 2, then it will becomes mv square by 2 into mr square. But mv square by 2 is nothing but kinetic energy. So as per this, kinetic energy into mr square. So x square by 2 equal to kinetic energy into mr square. So therefore, kinetic energy of the electron with angular momentum x. Just we have to change this expression. So that is nothing but x square by 2 into m r square. So like this, you have to derive the relation between kinetic energy and angular momentum. Already x is nothing but angular momentum. So you should remember that relation. So that is enough regarding angular momentum of the electron as per Bohr's atomic model. And now another important concept in this Bohr's atomic model, that is nothing but radius of an orbit. That means, imagine this is the nucleus and here we are having an orbit like this. So the distance between the center of the nucleus and this orbit, that is called radius. Of course, he proposed one equation. Now, if you observe the general expression to find out the radius of nth orbit, that is nothing but n square h square by 4 pi square into m into e square into z. So you should know the general expression also. Of course, we are considering in CGS units. Now, if you observe this, here we are having the constant h, 4 pi square, m and e. All they are constants except n and z. So on simplification, here we get Rn equal to 0.529 into 10 power minus 8 into n square by z centimeters. So this is the general expression to find out radius of any orbit in any atom, where n is number of orbit and z is atomic number, that is in centimeters. Or otherwise, here we can mention Rn equal to 0.529 into n square by z angstroms, because 1 angstrom is 10 power minus 8 centimeters. So like this, you should remember that general expression. According to this, here Rn is proportional to n square by z. Therefore, R1 by R2 means if you want to compare the ratios, here it is nothing but n1 square by z1 into z2 by n2 square. This is one of the important relations. They used to give radius of one orbit. You have to find out radius of another one. At that instant, you have to use this. If it is in the same atom, z is going to be cancelled. In different atoms means we have to use the atomic numbers. So that is how to find out radius of any orbit in any atom according to Bohr's model. So be clear about these three relations. Okay, and after that, suppose if you observe any two orbits, for example successive orbits, not only successive, you can consider any one. See, for example, here there are two orbits. This is one and it is one. Let it be first orbit and it is second orbit. So now, radius of first orbit, that is R1. This is R1. And radius of the second orbit, let it be R2. Now, what is the difference in the sizes of first and second orbit? Means here you have to find out this distance. Means the gap present between second and first orbit. Let it be delta R. So how to find out that? So what is the distance between first and second orbit? Of course it is nothing but R2 minus R1. But here if you observe for any two successive orbits. So here for two successive orbits, we are considering for two successive orbits. So as per the diagram, here delta R, that is nothing but R2 minus R1. Now what is R2 point? I think in angstroms I am giving 529 into N2 square. Of course, that is nothing but 2 minus 0.529 into N1 square. So 0.529 is common. So that is 0.529 into N2 square minus N1 square in angstroms. Since we considered the successive orbits, here N2 square minus N1 square means A square minus B square. That is A plus B into A minus B. So here delta R, that is equal to 0.529 into A plus B. That means here we can consider as N2 plus N1 into N2 minus N1. But since the concept is for successive orbits, for any successive orbits, N2 minus N1 will be equal to 1. 2 minus 1, 1. 3 minus 2, 1. 4 minus 3, 1. So it will becomes 1. So finally, that is delta R equal to 0.529 into N2 plus N1 angstroms. This is for any two successive orbits. That's why I mentioned at the beginning itself. For two successive orbits we are considering. Because here N2 minus N1 will be equal to 1. For any two successive orbits. So like this, you have to find out the distance between any two successive orbits. This is one part in Bohr's model. Now, sometimes in view of hydrogen atoms, suppose if you observe R1, R2, R3, means we have to compare the ratio of their radii. So, as per hydrogen atom, not only hydrogen atom, in any atom, suppose if you consider helium, for all the three orbits Z is common. Or if you consider the lithium, for any orbit Z is going to be common. So that's why here another important point, R1 is to R2 is to R3. We are considering first three orbits like this. This is, let it be R3. So what about the ratio? What is the general formula? Here, general, if you observe the solution, Rn, that is equal to 0.529 into n square angstroms or n square by z angstroms. Now R1, 0.529 into 1 square, R2, 0.529 into 2 square, R3, 0.529 into 3 square. That means, according to that, 0.529 and z is common for given atom of the element. So therefore, R1 is to R2 is to R3. That is nothing but 1 is to 4 is to 9. 1 square, 2 square and 3 square. So like this, you have to compare the ratios. This is another important point as far as radius is concerned. And sometimes, since we know the radius and those orbits are circular, so now another important concept regarding orbit, that is nothing but area covered by the orbit. Area covered by an orbit, whatever it may be. either it is first orbit or second orbit or third orbit. That means this is the nucleus, and imagine this is the first orbit and it is the second orbit. So what about the area covered by first orbit? What about the area covered by second orbit? After that, what about the ratio of the areas of both first and second orbit? For that, here, since they are circular, as you know the formula, area of nth orbit, let it be An. So since they are circular, that means An will be equal to pi Rn square, where Rn is radius of that particular orbit. So now, if you simplify by using the concept of radius, here for any orbit, the area of nth orbit, it is nothing but 8.8 into 10 power minus 17 into n power 4 by z square centimeter square. This is the general formula. Just by simplifying this expression, you will get this in CGS system. So this is the formula to find out area of given orbit in given atom. Now, according to this, we have one relation, that is An is proportional to n power 4 by z square. So now we can mention A1 by A2 equal to n14 by z1 square into z2 square by n2 power 4. Or otherwise we can mention n1 by n2 whole power 4 into z2 by z1 whole square. So this formula you have to remember to compare the area covered by any two orbits. So that is regarding the concepts related to radius. So first one is angular momentum, and then after that radius of given orbit and ratio of the radii, difference between the radii of two successive orbits, and after that area covered by the orbits. So this is one part in Bohr's atomic model. Like this, we have to discuss regarding velocity, energy, time period, everything that we'll see next commencing class.